Okay, so this is our first lesson. It is Monday, 8/19 of 18. We are going to be talking today about domain and range. We're going to be talking about the coordinate planes, mapping relations, and we're going to finally talk about functions and how we can tell if a relation is a function. So first thing you do, you go to your Algebra 2 Schoology page, click on today's date, Monday, 8/19/18. Brings this up, lesson 1, representing functions. And then if we want, you can click on your notes. And there comes our notes. We're going to make it a little bit bigger so we can write on it and be able to see what we're doing. Okay. So first thing we're going to talk about is domain and range. You guys have all heard these terms before. We've talked about them in every other class you've had as far as back to like 7th grade. So this shouldn't be anything new, but we are going to talk about what they are and how we can go through these, because we're going to be talking about them and finding them in functions for the rest of the school year. So it's important that you learn it now. Okay, a relation is just a set of ordered pairs. So any set of ordered pairs, remember, an ordered pair is just an x coordinate and a y coordinate with parentheses and a comma in between them. That's an ordered pair. So a set of ordered pairs is a relation. Okay, so in a relation, we have a domain and a range. The domain is all the x coordinates. The range is all the y coordinates. Sometimes you hear domain, especially with functions, we'll hear input and output, or independent variable. There's different ways to write that, different ways to talk about it. But for what we're doing now, you just want to look at your x coordinates and your y coordinates and the ordered pairs of your relation. So the first one here, it says, state the domain and range of this relation. So our relation is these ordered pairs. The domain is all the x coordinates. So -3, 0, 1, and 2 is the domain for this relation. The range would be 3, -7, -5, and 4. That's the range for this relation. So it really is that simple. What numbers are the x coordinate? That's your domain. What numbers are the y coordinate? That's your range. Okay, so that's domain and range of a relation. Really simple stuff. So now we're going to look down here at the quadrants on the coordinate plane. You guys have seen these before many, many times. If you don't remember what they're called, we'll go through that. And we'll change colors, make it green. Coordinate plane is divided into 4 quadrants. It's divided by the axes. You've got the y-axis that goes up and down, the x-axis that goes left and right. So the 4 quadrants are 1, 2, 3, and 4. And it makes a C. It starts in the top right, and makes a C, goes around to the 4th. So 1, 2, 3, and 4. And one way we're going to look at this has to do with the whether or not the x and y coordinates are positive or negative. If you look at quadrant 1, it goes to the right on the x-axis, so those are positive numbers. It goes up on the y-axis, so those are positive. So every point in this quadrant is going to have a positive x and a positive y. Fairly simple, right? So if we look at quadrant 2 over here, now it's going to the left of the origin. Remember, the middle is called the origin. So those are going to be negative x values, still going up, so those are positive y values. So these are going to be negative x, positive y. Quadrant 3, it's going to the left on x, down on y, so those are both negative. So x and y coordinates are both negative. Quadrant 4 goes to the right, so that's positive x, goes down, so that's negative y. So quadrant 4 has a positive x and a negative y value. So we can use that information, and it's self-explanatory. We can use that to tell, and down here we've got some examples. What quadrant would you find each of these points? -4, 6. Positive 4, -6. 4 goes to the right, and then down 6. So that's down here. So that's going to be in the 4th quadrant. The next one, 3, 6, goes to the right 3, up 6. They're both positive, so that's in the 1st quadrant. -5, -9, those are both negative, so it has to be in the 3rd quadrant. To the left 5, down 9, somewhere down here. So that's third quadrant. So this should be fairly easy for you guys. The next one, -6, 8. So it's to the left 6, up 8. The left and up means it's going to be in quadrant 2. It'll go away. Okay, the next one, -2, +2. -2, +2 is right there. Still quadrant 2. Next one, 16, 19. Those are both positive numbers, so it has to be in quadrant 1. So that's all there is to that. You look at what the values are, if they're positive or negative for your x or y value, and that helps you decide if it's going to be in quadrant 1, 2, 3, or 4. And always remember when you're drawing the graph, 1, 2, 3, 4, it makes a big C. 1 starts in the upper right, 2, 3, 4. All right. So that's all there is to the coordinate plane, Cartesian plane, and seeing the quadrants on there. It's not very difficult today. We move down. And now we're going to talk about mapping. Mapping is something that I'm not real big fan of just because we don't use it very much. No, those are blue, so we'll change this to red. Okay, we don't use this very much. It really just has to do with relations. Sometimes it's helpful to tell if it's a function or not, but basically when we're mapping, all we're going to do is we're going to draw two boxes. One's the domain values, one is the range values, and we're going to draw a line that shows which one goes with which. So here we've got a domain of 2, -8, 1, and 3, and the range of 4, 0, 5, and 1. 2 goes with 4. -8 goes with 0, 1 goes with 5, 3 goes with 1. So that's all there is to mapping. If I were to write these out as coordinate points, it would be 2, 4, -8, come on, -8, 0, 1, 5, and 3, 1. So this relation is made up of these points, and here's a mapping representation of it. Okay, this one over here is a little bit different. We've got a domain that only has 3 elements, 2, -8, and 1. The range has 4 elements, 4, 0, 5, and 3. So the difference here is that our coordinate points, this one goes here, this one goes here, but 1 goes to both 5 and 3. So if I write those coordinate points, I'd get 2, 4, -8, 0, and then we've got 2 more. We've got 1 and 5, and we've got 1 and 3. So the domain element 1 goes with both 5 and 3. So that's going to give us 2 separate points. So we still have 4 points in our relation, but 2 of them have the same domain value. And because it's a relation, we don't really care. That works just fine. Okay, so now we're going to talk about functions. Functions are, like I said, one of the most important things we talk about because everything we talk about is a function. So what is a function? Really, a function is just a relation in which each element of the domain is paired with exactly one element in the range. So it's really a special kind of relation. Still made up of coordinate points, or it could be made up of a line, which is made up of coordinate points. So a function is just a relation, but what's special about it is this relation only has one element of the range, or each element of the domain is paired with only one element of the range. So like the second relation we had just a minute ago when mapping is not going to work as a function because the domain value of 1 was paired with 2 elements in the range. So that's the difference. When we look here, we've got 2 different representations. We've got coordinate points here. We've got it graphed here. These are both relations. So let's look at whether or not they're a function. So first it says state the domain and range. So the domain would be 10, 6, 7, and -8. The range is going to be 3, -2, 4, and -9. If we were to map this, because we know the coordinate points, we know that each element of the domain only goes to one element of the range. So that means that yes, this is a function. Okay, so again, each element in the domain only goes to one element in the range, so that has to be a function. Down here we've got it graphed. We've got points that are graphs. So it's the same thing here, it's just represented as points on a graph instead of coordinate written out as ordered pairs. So again, we're going to do the same thing. What's the domain? And what's the range? Our domain value, if we look at the domain and range for this point, the domain is -3, the range is 2. For this point, it's -1 and -1. For this one, it's 0 and -3. Well, I'm not sure why it keeps doing that. For this one, it's 1 and 0. And then this one over here is 4 and 2. Okay, so again, is this a function? Well, -3 only maps to 2. -1 only maps to a -1. 0 only maps to -3. 1 only maps to 0. And 4 only maps to 2. Okay, one thing that could confuse you here, is we've got two range values that are the same. That's fine because each one of them is paired with a different domain value. If two elements on the domain were the same, then we would have a problem. But because two elements on the range are the same, it's not a big deal. So yes, this is a function. Okay, so that's basically all we're doing in this lesson. Should be fairly simple stuff. We'll move down real quick and look at the partner questions. And this is what you're going to answer together with the person sitting next to you. First one is, will every relation be a function? This should be an easy one. We've already had an example answering that. So on your whiteboard, will every relation be a function? If yes, we know it's not yes, okay? We know the answer is going to be no. So just give me an example that would tell me when it's not a function. Okay, and then the second question here, is there a simple test we can use to see if a graph is a function? Okay, you should remember this. This isn't that hard. It's something that you went over before. It might have been a little while, but there is a simple test. So what's it called and how does it work? Okay, I'm going to give you guys just a minute to write on your boards, write your answers, and then we'll go through them real quick. Okay, so first one, will every relation be a function? No, it won't. Okay, all you really need to do here is give an example, is just give an example of a relation that's not a function. So we could have 2 points, just like we did a minute ago, with a domain of 1 and a range of 0, or a domain of 1 and a range of 4. Here we've got a relation because there's 2 ordered pairs. It's not a function because 1 in the domain is paired with both 0 and 4 in the range. I don't care what points you put there. It's easy enough to do this. Any 2 points that has the same domain but a different range, that's going to be a relation that's not a function. And second one, is there a simple test we can use to see if the graph is a function? Yes. It's called the vertical line test. Okay, vertical line test. And here's how this works. If we look at this problem up here, number 5, we already said, yes, this is a function. We've got elements, domain and range here, 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 and here graphed out. So vertical line test works, on a graph. If we draw a vertical line through every one of these points that's in the relation, maybe a little more vertical than that one. Okay, if the vertical line goes through only one, if every vertical line you draw goes through only one point, then it's a function. If we drew a vertical line and it went through 2 points, then it would not be a function. So the vertical line test here tells us that yes, it is a function. Okay. That's all there is to it. Vertical line test, really easy, comes in handy quite a bit. Okay, so that's all there is for this lesson. If we go back to the Schoology page, the homework is the second thing on here. Quick things on here. It says questions 1 through 14, write the domain range of each relation and state whether or not it's a function. Okay, same thing we did basically. You've got examples that are written out as coordinate points. You've got examples that are mapped and examples that are graphed. You're just going to do the same thing. And the only problem here is that this should say 16. 1 through 16. Okay, and then you go to the bottom of this page. And the last thing on here is 17 through 20, name the quadrant in which each point's located. So all you have to do is tell 1, 2, 3, 4, which quadrant are these points in? And that's all there is to that for the homework. If we go back to this page, we can see it's due on the 22nd, which is Wednesday. So you've got a couple days to get that done. Shouldn't be too hard to do. And if you forget how to do any of this, hopefully you won't, but if you do, you can come back, click right here, and watch the video of the lesson again, or always come and see me during tutorials. So that's all there is to that, and good luck.